everybody, welcome back to Algebra 3. Today we are going to be starting a new chapter all about angles and their measures. So we're going to review vertical angles, linear pairs, complementary and supplementary angles, and then I'll also show you some stuff about coterminal angles and how you can use them. So let's get started. First of all, just some review of terminology. Acute, right, obtuse, and straight angles are angles that you may have seen in geometry before. Acute means that the angle is between 0 and 90 degrees, so it's a small angle. A right angle is a 90-degree angle, and I can tell it's a right angle because it's got this little box here. So that little box means right angle. An obtuse angle is an angle that has a measure between 90 and 180 degrees, and a straight angle is 180 degrees, makes a straight line. And so here's some sketches of angles that you may be familiar with or you may have had to draw before. If I were to ask you to draw these, I would, if I were going to draw these, a 45-degree angle would be an acute, so I would know it should be acute. 20 would be smaller than that. 150 would be obtuse. 130 would be a little bit smaller than that. Now, I think you've seen angles with these types of measures before. And there's also some types of angles we need to review. One are called vertical angles. Now, vertical angles are angles that are right across from each other. And we can also look at the ones across from here too. Vertical angles are the angles that make the x, are across from each other on the x. And the cool thing about vertical angles is that they are congruent or equal. Their measures are equal. Congruent means same size, same shape. So if I were to tell you that this angle was a 60-degree angle, then the angle right across from it is also 60 degrees. Linear pairs are two angles, this one and this one, that make a straight line. So if I put them together, they form this nice straight line. Linear pairs are supplementary angles, S-U-P-P-L-E-M-E-N-T-A-R-Y, supplementary. Now, what are supplementary angles? Supplementary angles are angles that add to be 180 degrees. So what's nice about supplementary is or a linear pair is if you know one of them, you can figure out the other because they're supplementary. So if I know that this angle is 30 degrees and I know that I have a linear pair, then I can find the other one by doing, let's call this x. X plus 30, they have to add to be 180 degrees. I can subtract 30 on both sides. X would be 150. So this angle x measures 150 degrees. Complementary angles are angles that add to be 90 degrees. So I know that they would be 90 because they have that little box we talked about. So if I know these two are complementary, and I were to tell you this angle is 75 degrees, to find this other angle y, I could set up an equation. Y plus 75 is equal to 90. Subtract 75 on both sides, and I get 15. So y would have to be 15 degrees. So now you have some problems on Delta Math that need you to apply what we know about these types of angles. So I have this diagram here. I've got 50 degrees labeled. I have to find angle B and angle C. And so right away I see that, 50 degrees is right across from B, and I see two lines that form an X. So B and 50, we call those vertical angles. Vertical angles are equal, so B is equal to 50 degrees. And I still need to find C. Well, I see that 50 degrees and C make this line. So these two angles form a line, and that makes them a linear pair. And since they're a linear pair, these two angles have to add to equal 180. So I can set up an equation 50 plus C equals 180. I can subtract 50 on both sides, and C is 130 degrees. I have a linear pair here, These two angles make a line. So I can say that 29 plus A equals 180. Subtract the 29 on both sides. A equals 151. So this angle is 151 degrees. Now, you've seen angles that have these types of measures before, but have you ever seen very large or very small, like this number with the squiggle has negative? Ooh, did you know that they're possible? It is possible to draw angles. We can draw them by placing them on the coordinate plane. So I have the coordinate plane here, and I can draw angles in standard position. I'm going to move this line over for a second. Angles in standard position have two sides. So let me drag these over here. Two sides. So I have a red side and a blue side. Okay. The red side is called the initial side. Initial meaning like this is where you start from. The blue side we call the terminal side. I wrote blue. Terminal side. And so the initial tells you where you start, terminal tells you where you end. So the angle gets formed by starting the initial on top of the terminal right on top of the initial, and then I open them up, and now I have an angle. So when I draw an angle in standard position, I put the initial side, I'm going to keep the initial side red, put the initial side on the positive x-axis. The initial side is always on the positive x-axis. Okay? The terminal side, oops, terminal side, I need a blue one, there we go. Terminal side starts here, but then I open the angle as far as I want to form the angle. So if I were to stop here, I would indicate the direction that I'm opening the angle, and then I would give the measurement. Now when I open the angle from here and then go that way, I've passed a 90-degree angle, and then to right here would be 180. But then if I go add 90 more, 90 plus 180 is 270, and then all the way around the circle would be 360. So let's say that I wanted to draw a 300-degree angle. Well, first of all, I notice that 300 is between 270 and 360. So that tells me the terminal side should be somewhere in between here. So what I'll do is I'll start my terminal side right here. And then I'm going to open my angle past 90, past 180, past 270, and then till I get a little bit past 270, let's see, I got to go 30 more degrees right here. But then if I go all the way around this way, and it's really important that you draw this because that tells you which way the angle is opening, I have a 300-degree angle all the way around. If I wanted to do, I could even do 350 if I wanted to, get it really close. So then the angle would just go up here, 350. I can do that. I can even start here. Let's put that terminal side right here. I can even start here. I can go a 360-degree angle. A 360-degree angle is a complete rotation. Or if I wanted to draw a 400-degree angle, I would start at 360. Oh, sorry. I would start right here, start at 0. That's the initial terminal side. Come on now. There we go. I would start here, open the angle to 90, to 180, to 270, to 360, and then a little bit more to 400. And to show that I did that, I need to draw this arc. So I started at 0, went past 90, went past 180, went past 270, and then I went 40 more degrees to get a 400-degree angle. That's how you do it. So if I were to draw, let's see, what are some examples here? Like a 700-degree angle, I would just keep going until I got to 700 degrees. And I can go as many times around the circle as I want for positive angles. But also notice I was talking about negative angles. Well, for positive angles, when you start to draw the angle, you always go in the same direction. Positive angles start on the positive x-axis and they go up, right? Negative angles, so let's say I wanted to draw a negative 50-degree angle. Let's get rid of this. If I were to draw a negative 50 degrees, instead of going up, we need to go down. Get rid of this too. So start right here, this is 0. Then I would go backwards 50 degrees. So I would go the other direction, and that would be a negative 50-degree angle. The negative angle tells me that I'm going the other way around, and I could go negative 270, negative 360, but that's how I would go. So in standard position, an angle is in standard position if the initial side is on the positive x-axis. Positive angles move in a counterclockwise rotation, while negative angles move in a clockwise rotation. Now, I like to think positive angles, you move up. Positive is like an upward thinking word. Negative, you start the angles and go down. So you start down. Angles are measured. Right now, we're measuring all of our angles in degrees, and we denote them with this little degree symbol. And a degree is 1/360th of a rotation about the vertex. So there are 360 degrees in a circle. Now let's talk about coterminal angles. Coterminal angles are angles that have the same initial and same terminal sides. So I've got some angles drawn here already, and it looks like they're the exact same, maybe 40 to 20, 30-degree angle, but they're not. So let's start here. Let's say this angle right here is 30 degrees. But then to draw this next angle, 30 degrees, yes, but it's going to be different. I'm going to make it different by making it go all the way around the circle first and then to 30. So what happened, and it's really important that you draw the picture, you started here, I went all the way around the circle, that's 360 degrees, and then I went 30 more degrees. So this would be a 360 degrees plus the 30, 390-degree rotation. I could also draw the same angle by going backwards. So let's see. Let's say I started do the purple angle again. So on the initial side, instead of going up to be a positive angle, if I go down this direction and stop, then I have a negative angle. So going positive, it was 30 degrees, but going backwards, it's a negative angle, and it's negative 330 degrees. Because absolute values of these two, since it's just one rotation, should be 360. So you'll have some problems like this. It says find an angle that's coterminal to 889 degrees. So first of all, the first thing we want to do, number one, is we want to find how many rotations occurred or how many rotations there were by subtracting 360. Because every time you subtract 360, that's one rotation. So I take 889. If I subtract 360, that's one rotation. Okay, so that's like starting. Here's my initial side. And then I go, let's see. So 800, and so right here, that is 360 degrees, right? Okay. So 889 minus 360 is 529. Okay. Then I'm going to subtract another 360. That is saying I'm going to make a second rotation. So 529 minus 360 is 169. Oh, wait, hold on. I need to make another rotation. So make another rotation. So first and second rotations made. 529 minus 360 is 169. So that means there's 169 degrees left. So about right here, this would be an 889 degree angle. So they made one rotation, two rotations, and then 169 degrees more. Well, the directions say find an angle from 0 to 360. Oh, look, that's what I have right here. That's coterminal 889. Well, I would be in the same place if I just start here and draw a 169 degree angle. There. So the angle that's coterminal to 889, that's also between 0 and 360, 169 degrees. Now, there are infinitely many coterminal angles to 889 because I could keep going around in the circle or I could go the other direction. But I'm being specifically asked for the one that's between 0 and 360. We can also do this with negative angles. For negative angles, so if you looked at, we had a positive angle and I had to subtract to find how many rotations. If you have a negative angle, we're going to add 360 to find how many rotations. So I had negative 399. If I add 360, I get negative 39. So adding the 360, that's the first rotation. I need to add until I get to a number between 0 and 360. So I'm going to add another 360. And I get 321. Adding that 360 is the second rotation. So what that means is if I draw a 321 degree angle, because I know it's 321, you got to go to the 90 degrees. If I go here, that would be 180 degrees. Down here would be 270. And then all the way around would be 360. So I don't want to go all the way to 360. So I just want to stop at 321. But the 321 degree angle is coterminal with, if I made two rotations backwards, so that's one rotation. One rotation. And then the second rotation right there. Would also be coterminal. So I would enter 321. So to find the coterminal for positive angles, you're going to subtract 360 until you get a number between 0 and 360 degrees. For if you have a negative angle, you're going to add 360 until you get a number between 0 and 360. All right, so that should be enough to get you through the assignment for today. Have a wonderful day. I'll see you all later.